It all began with a faint glimmer in the vast expanse of space on July 1st, 2025, a discovery that would captivate astronomers, spark global debates, and ignite imaginations worldwide. The Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope in Rio Hurtado, Chile, funded by NASA, picked up an unusual object streaking through our solar system. Initially designated as the 11PL3Z, it was soon confirmed as an interstellar comet, the third of its kind ever detected, and officially named 3I/ATLAS, or C/2025N1ATLAS. Unlike the rogue visitors Oumuamua in 2017 and Borisov in 2019, this one arrived from the direction of the constellation Sagittarius, hurtling toward the sun at an astonishing speed of around 152,000 miles per hour, nearly twice the velocity of its predecessors. As data streamed in from observatories around the globe, what started as a routine detection evolved into a profound mystery, blending cutting-edge science with tantalizing what-if scenarios that challenge our understanding of the cosmos. Stick with me through this journey, because by the end, you'll see why 3I/ATLAS isn't just another space rock. It's a window into the unknown that could redefine humanity's place in the universe. To truly appreciate the enigma of 3I/ATLAS, we must first rewind to the basics of interstellar objects and why they fascinate us. Our solar system is a bustling neighborhood of planets, asteroids, and comets, all bound by the sun's gravity in elliptical orbits. But interstellar objects are cosmic nomads, ejected from distant star systems billions of years ago, wandering the Milky Way until gravity slings them through ours. The first 1I/Oumuamua, discovered by the Pan-STARRS telescope in Hawaii, was a cigar-shaped enigma roughly 1,300 feet long, tumbling end over end with an unusual acceleration that some attributed to outgassing hydrogen. Though Harvard astronomer Avi Loeb famously speculated it might be an alien probe or light sail. Then came 2I/Borisov in 2019, a more traditional comet with a dusty tail, rich in carbon monoxide, hinting at formation around a carbon-rich star. Now in 2025, 3I/ATLAS joins this elite club, but with quirks that set it apart. As of September 29, 2025, observations from telescopes like Gemini South, Hubble, and the James Webb Space Telescope, JWST, have revealed a comet that's not just passing through, it's behaving in ways that defy easy explanation, prompting whispers of deeper cosmic secrets. Imagine a traveler from another world, carrying clues about alien chemistries or even ancient technologies. While science demands evidence, the anomalies here are real, and exploring them could unlock breakthroughs. Keep reading, because the deeper we dive, the more compelling this story becomes. The initial excitement surged when pre-discovery images from ATLAS telescopes worldwide and the Zwicky Transient Facility at Palomar Observatory extended the observation arc back to June 2025. This allowed astronomers to plot its hyperbolic trajectory, a path that's not closed like our native comets, but an open curve, confirming its interstellar origin. Currently, as of late September 2025, 3I/ATLAS is about 420 million miles from Earth, well beyond Mars, and poses no threat. Its closest approach to our planet will be around 1.8 astronomical units, AU, or about 170 million miles safely distant. Yet its size alone is staggering. Estimates suggest a nucleus up to 5.6 kilometers, 3.5 miles across, making it far larger than Oumuamua or Borisov. A recent study by Avi Loeb, published on September 25, 2025, calculates its mass at over 33 billion tons based on JWST data from August 6, 2025, 3 to 5 orders of magnitude heavier than previous interstellar visitors. This anomalously massive nature explains a key puzzle. Despite vigorous outgassing, there's no detectable non-gravitational acceleration, the kind comets usually exhibit from jet-like emissions, pushing them off course. In essence, 3I/ATLAS is so hefty that its own eruptions barely budge it, like a supertanker unmoved by ocean waves. But why such mass? Could it be a fragment of a shattered planet from a distant system, or something more engineered? As we peel back the layers, these questions build suspense. Don't stop now. The chemical revelations are where things get truly eerie. Diving into the chemistry, courtesy of JWST's groundbreaking observations, unveils a composition that's outright bizarre. On August 6, 2025, JWST turned its NIR spec instrument toward 3I/ATLAS in an emergency override mode, a rare protocol reserved for high-priority anomalies, interrupting scheduled deep space surveys. The spectra revealed a coma, the gaseous envelope around the nucleus, dominated by carbon dioxide, CO2, at levels 8 times higher than water vapor. For context, typical solar system comets like Hale-Bopp or Hyakutake show CO2 to water ratios around 0.5 to 0.7. Even Borisov hovered at 0.5. This 8-to-1 imbalance is unprecedented, suggesting 3I/ATLAS formed in a carbon-rich environment far from any sun-like star, perhaps around a red dwarf or in the outer fringes of a protoplanetary disk. But the real shocker: strong nickel spectral lines in the ultraviolet and near-infrared, with emissions spiking as the comet nears the sun. Nickel vapors at rates exceeding 10 to the 21st atoms per second, increasing by an order of magnitude between 3.8 astronomical units and 2.85 astronomical units. In natural bodies, nickel pairs with iron in a 1:15 ratio, forged in stellar explosions and preserved in meteorites. Yet in 3I/ATLAS, iron signals are conspicuously absent across multiple instruments. No traces, no noise, just flatlines. This separation defies natural processes. On Earth, isolating nickel from iron requires industrial smelters and high-energy chemistry. Is this a hint of artificial refinement? Speculative, yes, but grounded in data. Loeb's team notes the possibility of nickel carbonyl, a volatile compound, but even that doesn't fully explain the iron void. As the comet brightens 5 times faster than predicted by mid-September 2025, these traits paint a picture of a body that's not just alien in origin, but potentially alien in design. Imagine the implications: a relic from a long-extinct civilization, or a probe venting exotic fuels. The suspense mounts with every new dataset. Stay tuned as we explore the behavioral oddities that amplify the intrigue. Beyond chemistry, 3I/ATLAS's dynamics add layers of mystery. As it barrels toward perihelion, closest solar approach, on October 30th, 2025, at 1.4 astronomical units, just inside Mars' orbit. Its velocity and path show peculiarities. Hyperbolic orbits mean interstellar objects zip in and out without lingering. But 3I/ATLAS's trajectory aligns unusually with the solar system's ecliptic plane, the flat disk where planets orbit. Statistically improbable, this has fueled Loeb's speculation of intentional navigation, though critics like Chris Lintott dismiss it as coincidence. More intriguingly, despite copious outgassing, evident in its coma and short tail, the comet exhibits no non-gravitational acceleration. Upper limits from over 4,022 observations peg residuals at 0.028 arcseconds, implying any thrust is below 15 meters per day squared. For a lighter comet, this would be impossible. Outgassing should alter its course like rocket exhaust. But with its colossal mass, the effect is negligible, suggesting a dense, solid core unlike the porous ice balls we're used to. Photometric data from Gemini South and TESS hint at periodic brightness variations every few hours, though not as clockwork as speculated, perhaps due to rotation or uneven venting. As it nears Mars in early October 2025, passing 18 million miles away, missions like NASA's Perseverance rover and orbiters could provide unprecedented views, potentially detecting subtle maneuvers. What if this isn't random drift but programmed flight? While NASA debunks alien claims, emphasizing natural explanations, the anomalies persist, urging us to question, Is 3I/A TLAS a harbinger of more visitors or a singular puzzle? The story unfolds in real time. Keep following as we connect it to Earth's ancient skies. Linking 3I/A TLAS to humanity's past adds a haunting dimension, blending archaeology with astronomy. Ancient civilizations revered sky metals, meteorites high in nickel, like the 11% nickel blade in King Tutankhamun's tomb, impossible with Bronze Age tech, but matching cosmic alloys. Babylonian texts describe falling stars as omens, and artifacts from the Near East show nickel-rich compositions absent in terrestrial ores. The Widmanstätten patterns, crystalline bands unique to slow-cooled space metals, etch these relics, whispering of extraterrestrial origins. Now in 2025, 3I/ATLAS's nickel dominance echoes these signatures, minus the iron. Could fragments from similar objects have seeded Earth's myths? Loeb posits that interstellar debris might explain such anomalies, perhaps even influencing early life via panspermia, where microbes hitch rides on comets. While speculative, it's rooted in science. Comets deliver organics, and 3I/ATLAS's CO2-rich coma could carry prebiotic molecules. As thermal data from JWST reveals faint electromagnetic rhythms, sonified into prime number cadences reminiscent of DNA helices or Fibonacci sequences, the what-if grows. Is this a natural harmonic or an encoded signal? No strong broadcasts detected, but the pattern's subtlety suggests a passive marker, audible only to close observers. With Earth's magnetic field showing minor ULF pulses in sync, though likely coincidental solar activity, the narrative teases a cosmic connection. Don't dismiss it yet. Historical precedents like the WOW signal from Sagittarius amplify the allure, making 3I/ATLAS feel like a chapter in an ongoing saga. As observations mount, the debate intensifies, pitting skeptics against visionaries. NASA and ESA emphasize natural causes. 3I/ATLAS likely hails from the galactic disk, ejected by stellar encounters eons ago, its chemistry forged in a unique stellar nursery. Yet Loeb's September 2025 paper highlights 6 coincidences and 8 anomalies, including rapid brightening, 5-fold instead of 1.5, unusual composition, and collision-avoiding path. Social media buzzes with theories. Users like at Jinxed Horizon cite its Sagittarius origin, tying it to the 1977 WOW signal, while others speculate alien reconnaissance. Debunked by experts, these ideas persist because science thrives on questioning. JWST's August 26, 2025, images show a ghostly coma with minimal dust, controlled emissions hinting at internal mechanisms. As it approaches perihelion, brightness could peak at magnitude 8 to 10, visible through binoculars from dark sites. But what if it fragments, like some predict due to intense heating, or darkens abruptly, as models suggest post-perihelion? Simulations match 92.6% with engineered trajectories, dodging planets with precision, eerie but explainable by gravity. Still, the mass anomaly challenges models. Why so dense? A rocky core with metallic enrichment, or artificial? Balancing fact and fiction, remember this is speculative entertainment, compliant with YouTube's truth standards. No harm, just wonder. The real thrill? It encourages stargazing, fostering curiosity about our universe. Expanding on JWST's role, this $10 billion marvel, launched in 2021, orbits at L2, a million miles from Earth, its infrared eyes piercing dust veils. For 3I/ATLAS, NIRCAM, and NIRSPEC captured the coma's glow, revealing CO2 dominance and nickel spikes. Data released August 28, 2025, by Smithsonian. Compared to Borisov's CO-rich profile, this suggests diverse interstellar birthplaces. But absent iron, cross-checks with VLT and Gemini confirm no Fe lines at expected wavelengths. Natural separation might occur via volatilization, but at such scales? Rare. Add the lack of dust chaos, coma thin, emission smooth, and it evokes controlled venting, like a spacecraft. Historical parallels. Oumuamua's acceleration, now attributed to hydrogen, but Loeb's light sail theory lingers. 3I/ATLAS, with no such thrust, flips the script, too massive for natural push. As it nears Saturn's orbit post-perihelion, potential relay effects? Fictional, but JWST's September anomalies in distant quasars, unrelated fuel imagination. Ground truths. It's a comet, but anomalies invite exploration. Engage by observing. Download apps like Sky Safari for tracking. The endgame? If it survives, it'll exit by 2026, leaving data for decades. But the questions endure, urging us to watch the skies. In the broader context of 2025's astronomical wonders, 3I/ATLAS stands out amid a year of discoveries. JWST uncovered 300 universe breakers, early galaxies defying models, and a primordial black hole in Abell 2744. A five-galaxy merger, a lava planet's atmosphere on TOI 561b, even a new Uranian moon S/2025 U1. Saturn's dark beads in its hexagon jet, unexplained magnetosphere interactions. Yet 3I/ATLAS's interstellar status elevates it, hinting at galactic abundance. Estimates suggest thousands pass yearly, most undetected. Rubin Observatory, launching soon, could spot more. Implications? If anomalies persist, it bolsters SETI efforts, like Galileo Project hunting technosignatures. Historically, comets omen change. Halley's in 1066 preceded conquests. Today they inspire unity as global teams collaborate. Speculatively, if engineered, it's recalibration. Not invasion, but activation of dormant systems. Earth echoes? Coincidental, but magnetic pulses in Antarctica align temporally. Solar flare linked. Lunar pings? Archival Oumuamua data shows faint modulations. Noise or pattern? As 3I/ATLAS darkens post-perihelion, perhaps shutdown mode, blending into void. The horror? Not contact, but realization we're part of a larger machine, ticking since before dinosaurs. To engage fully, consider the scientific method. Hypothesis, test, refine. For 3I/ATLAS, hypotheses abound. Natural oddity versus artifact. Data tilts natural, but gaps allow wonder. Expand your knowledge. Read Loeb's Interstellar or watch JWST docs. Observe. October 3rd, 2025. Mars flyby. Use telescopes for views. Notifications on next anomaly could be tomorrow. Share. Discuss in comments, beginning or continuation. The scariest? Discoveries waiting when we look up.